Hi, I'm Kimberly, and this is my eMath 2 assignment presentation. So here we have the claim that the average timing for a 17 to 19-year-old girl to swim a 50-meter breaststroke is 62 seconds. This will be our null hypothesis H naught, which we could put as mu is equal to 62. Then H1, our alternative hypothesis, will be mu is not equal to 62, which will then be a two-tailed test, as in order to prove H naught wrong, we could either find more than or less than the mu. So over here, I just copied down the mu and the significance level A, which I found by taking 5% divided by 100. So yeah, 5%, which will be 0.005. So for sample size, I collected this data from a recent swim meet in SG. So then the sample size for the age group was 36. I used by counting the cells here. Sample mean X bar by finding the average of the cells here. Sample standard deviation S, as sigma was not given, and S will help later on when testing the statistics T naught. So in this case, standard deviation dot S of these cells. So testing the statistics T naught, I use t-test as I said previously. Sigma was not given, so I use S. So in this case, for the formula over here, it is X bar, so my mean, minus my population mean, mu, over S, divided by square root of the sample size. So this gave me this value over here. So then we find the p-value, which is the probability of getting the sample stat, or something more extreme in the direction of H1, when H0 is true, H0 is true. So we use this formula, T asterisk T distribution dot RT, absolute value of the test stat, comma, the sample size minus 1, which gave me this. So actually from this, we could already conclude that p-value is less than alpha, which then we could reject the null hypothesis. But we shall conclude further tests to see if it's true. So we found the margin of error, which will help us also later in the 95% confidence interval. So we found this by using this confidence T, G6 being alpha, standard deviation S, and the size of the data. After which, oops. After which, we construct the 95% confidence interval, where X bar minus the margin of error is the minimum, and X bar plus the margin of error is the maximum. So then we plug in the values here, which is 50.99, less than mu, less than 59.58. So from here, since the mu is 62 and isn't found in the 95% confidence interval, there's sufficient evidence to further reject the claim. Thank you.